Good afternoon and good morning, everyone. Welcome to our TruLaser 2D webinar. Today, we're going to take you through a very interesting topic. It's a new feature here at Trump called Power by the Hour. My name is Soleil Quaranza. I'm the TruLaser product manager here in North America, and joining me today is going to be Brett Thompson and Ryan Keefe, sales engineer and applications engineer each. They are extremely knowledgeable and excited to walk you guys through this with me. So what we're going to do is just show you a couple of short slides to explain the mechanics of how this feature works, where you might benefit from it, the productivity you could expect from this kind of a feature, and then we'll get into some live cutting to show you the differences in different parts that you could run through this type of a program. So without further delay, I am going to go ahead and share for you guys this presentation. So Brett, if you might just confirm for me that you can see our slides.
Indeed, it's the lovely front screen that I put on. Everybody, I'm going to claim credit for that. Looks fantastic.
Wonderful. Very good. Okay, so away we go. Power by the Hour. So as I said, this is a unique feature that we have debuted for our customers here in the US and Canada. And effectively, we like to think of it as power by the hour or power on demand. And you really can utilize it when you need. And what you would do is you would get from us a TruLaser 1030 or 1040, or even something out of our 3000 series, the bigger machines there that you can see on the right. And you purchase the lower price point, the lower power level. In this case, for the 1 series, that would be a 2 kilowatt, which is our standard power level. And then on the 3 series, that would be our 6 kilowatt power level. It's actually not the lowest power level on this machine, but that's where we start for this program. So that's your investment of the machine, the price point. But if you enroll in Power by the Hour program with us, you will have delivered actually the higher power level there that we're showing. So on the 1 series, that's the 6 kilowatt, 6001 TruDisc. And then on the TruLaser 3000 series, it's the 10 kilowatt that is delivered to your facility. And with this, what you can do then is you can boost your productivity as needed by utilizing that higher power level during your production, during your manufacturing. You at any time have the option, of course, to buy out to the higher power level, but if you don't, whenever you enact or enable that higher power level, then the system will track how many minutes you were running at that higher power level, and then we would invoice you at a cost of $1 per minute, or $60 per hour. But we don't round up to the hour, I promise you that. Again, this is options for you to, if you find you are always running at that higher power level, that's just what you've grown into. You've taken on so many jobs or so much work that you're always operating near 100% at the higher power level, and you want to do that, you can just go ahead and outright buy it for $225,000. Trump Finance is happy also to come along with us on this program, and so they would evaluate from a finance perspective the availability for you at the lower price point of the machine. And they don't have a financing option on the usage, that minute usage. That's just handled by Trump Inc. We can get into some questions about that later if you guys are more curious about it. But let's talk about how this works. You don't need a Trump service technician to do this for you. With a little bit of training, when we do the installation of the machine, you and anyone in the facility can do this on your own, completely individual. So what I'm showing you here is a snapshot of the control panel on the machine, the HMI, if you will. And this is the case for a 3000 series machine, where you can see there's an extra tab called Power by the Hour configuration, where you would navigate over to, and here you would find your ability to make your power selection. Right now, this snapshot is the machine currently in a state where it's operating at the 6,000 watts. And say now we want to make the change. I'm going to show you just how simple this is. Watch, you're going to go and you're going to pick the Select Laser Power button Open that up, and there you can see are the two options for the machine, 6,000 watts and 10,000 watts, and we want to make that change to 10. So we're going to go ahead and we're going to click on 10, and now the machine is actually going to come up with a little notification to ask you one more time, are you sure that you want to do this? We do want to do this, actually. So you'd hit yes, but if this was an oops moment, you have another option to stop at this point and revert back to 6 kilowatts. But we do want to do this, so we're going to say yes, and we would click that button right there, the checkbox for yes. And the process to go in the back direction is exactly the same. When you make that selection for the other power level, whether you're going down or up, the system will reboot. And then when it comes back up, it will be in that different power level, utilizing the laser tech tables for that appropriate power. So once you've gotten into the higher power level, the machine will start tracking your minute usage. Let me show you also what that's going to look like. The machine has to be connected to the cloud for this to happen. And every month, every week if you'd like, every day if you'd like, you can go into your MyTrump account, and you can go ahead and you can look at how are we doing on our usage of each power level. We too will do this at the end of the month to understand how many minutes should we invoice you for at that higher power level. So this is just an example of a report. It's actually identified by machine serial number and month, and we will look for the total minute usage at the end of the month for 10,000 in this case again. But if you were using the 1 series, this would be then 6,000 watts on this column, and this column over here would say 2,000 watts. We total that up, again, figure out the math and how much to charge you, $1 per minute, and then we'd send you an invoice for that. So let's get deeper into a couple of the who benefits from this questions and look at what it has on as an impact goes on productivity for you. So to do that, Brett, can I ask you to take over the microphone?
Yeah, I suppose you could ask, and maybe I'll even comply. I can't actually see the screen right now. Last time I did this, you said, hey, the lighting's pretty poor. So I've literally got lights hanging down in front of me. So hopefully everybody can see me okay now. So what we wanted to do is just kind of step on through a couple of different, basically scenarios, because we know, of course, you're going to have more speed and capacity when it comes to higher laser powers. So we would move up, of course, when we want to have higher feed rates. If we want to increase kind of the burr limit, so if we're cutting with nitrogen, we're cutting with compressed air, a fusion process, we want to see a different level where the burr starts to go away. And then, of course, we have higher capacities. And so kind of looking at the two different ranges here, we have the 1 series machine. So that's 2 kilowatts to 6. That's the biggest jump. And you'll see the biggest difference in performance gains, which is what you're looking at on the graph here. Obviously, that's because you have a broader range of powers within the scope, but also what you're doing kind of in that mid-range when we get to the 180,000s that you see down here. You start to move into doing a nitrogen cut as opposed to an oxygen cut. So that's going to be another one of the things that really contributes to the higher throughputs. But then also we have to consider if we're using a nitrogen process that's nice and clean, I don't have to worry about removing the oxide before I go ahead and paint the part or weld it or whatever it might be. So there's definitely advantages to that beyond just the speed that you see here, but definitely you have really, really big gains in the absolute feed rate. So what we're looking at is just absolute feed rate. Slate, can you please go to the next slide? And so here we're looking at the 3 series laser. So again, the range is going to be 6 kilowatts and then skipping to 10 kilowatts. So you have these two different power levels that we're looking at. And you would see you have pretty big increases in the feed rates here, but you're also seeing that they're maybe not as substantial as some of the ones on the 1 series machine. And again, that's because here we're using a nitrogen process for everything. So even in the case of 1/2 inch with a 10 kilowatt laser, we can realistically cut 1/2 inch with nitrogen as opposed to oxygen if we want to. So it really does have the benefit of also being able to be fusion cut across the board. Where you really kind of see the big increases in that mid range. So when I look at 120 thousandths, 180 thousandths, and 1/4 inch, your gains are bigger than they are on either end. And the reason for that is we're using a nozzle technology called high-speed eco. And so here, since we're capturing really efficiently all the assist gases that are being used, we're able to really benefit from the higher laser power. So we don't have to kind of back off the speed a little bit because a lot of the assist gas is just blowing off the surface. Since it's all being forced through the kerf, you can see we get really, really big increases in feed rate here. And this is unique to the 3 series and 5 series lasers. So you generally get, compared to a normal cutting process, like you see on the 1030, a performance gain of up to about double. The 1/4 inch range a little bit less when you get into 3/8 and 1/2 inch. So pretty big performance increases as well. So can we go to the next slide, please? Okay, thank you. So what we did to kind of look at that from the perspective of what does this mean from a production level? Because in a lot of cases, when somebody's making a decision for what laser I'm going to choose, it's a decision that's based on what sort of work I have and what sort of work I'm maybe considering in the future, whether there's some possibility for growth. So what we did is we took just kind of a generic nest, 5x10 sheet of 1/4 inch, ran it on the 3030 as well as the 1030 at those 2 different power levels, 1/4 inch materials with whatever is the best process as far as assist gases are concerned. And what we wanted to see is, what is the difference in processing time? How much less percentage of time does it take at the higher power levels? So the 2 graphs, or the 2 bars that you see on the left side of the chart, that's the 1 series laser, right? And so you can see we have a pretty big jump there, and that's again because we'd be using oxygen, and I believe that's what we're going to do when we run the laser today. Oxygen for the 1/4 inch cut on the 2 kilowatt, we're going to be using nitrogen on the 6. So you're not only benefiting from higher laser power, but the fusion cut as well. So there's going to be a really big increase in the cutting speed there, as well as in the 3 series laser going from 6 to 10. And so when you're able to cut that much more quickly, we have to consider, okay, what does that mean from the perspective of a year's worth of production? So if I'm making a decision about which laser I should buy, so the machine platform, and then what laser power, I'm considering, okay, how much current work do I have? So if I have enough work to get me through 1 shift, if I have enough to get me through 2 shifts, I have to consider which machine is going to be able to do all the work that needs to be done within whatever the most efficient amount of time is. Can you please hop to the next slide, Soleil? Thank you. And so this is just a couple of the different scenarios of who might actually consider the power by the hour. There are definitely more cases, but I think really common ones for us, the people that have gone this route, fall into kind of 2 categories. Now, one would be somebody who says, okay, currently I have enough work for 1 shift at let's say 2,000 hours a year, right around that, at 261 days for the 2 kilowatt laser. Now, what does that mean for my future growth potential? So if I have a 2 kilowatt laser, that's what I've paid for, and that's what my investment is associated with. So when I'm figuring out my dollars and cents, my ROI, I'm saying, okay, the 2 kilowatt will do everything I need in a single shift here. And so now what I can do is I can start considering whether I want to grow my business. So I've got that 6 kilowatt. So now I'm saying I'm able to do everything that needs to be done within a single shift. Or if I use the 6 kilowatt, now I have the ability to do everything that needs to be done in about 40% less time than it would take in the scenario with the 2 kilowatt laser. That means I have quite a bit of additional time that I can go out and I can look for additional work for the machine. And so those are billable hours that are available for the laser. So that's going to help me build my business. So I'm able to, in a more risk-free manner, experience growth. So I have the laser that can accommodate greater throughput that I didn't actually pay for until I'm actually seeing that additional throughput. And that's really beneficial when we're in cases kind of like this now, where The economy is pretty good for manufacturing. We don't know where it's going to be in the future. So this is a really good way to kind of avoid some of the risks associated with investment. And then there are also those customers that say have a very specific known quantity. Maybe they're an OEM, maybe they're a job shop or a contract manufacturer, but they say the laser that I bought is definitely going to do every job that comes across my desk except for this one. So maybe the vast majority of what I do is thin gauge material, right? But there's that little bit of 1/4 inch that I want to cut the most efficient way possible, and that 6 kilowatts is going to be beneficial. Or it could be that I'm going to something really on the extreme. So your thickness capacity for the 1030 fiber with a 2 kilowatt is 5/8 of an inch steel. When you go to the 6 kilowatt, it's 1 inch, right? So if you have the need for occasional materials that are thicker than what the 2 kilowatt would be capable of cutting, certainly then you would have that benefit as well. So both of these are really good scenarios for us when we have not maybe necessarily a use for the higher laser power immediately, but we might in the future, or we won't need it in the future at a higher volume. We just need a little bit now. So I can't really justify buying the higher laser power for that just a little bit of work. Okay, so I think is this the end of our slides, Soleil? I think we're going to look at the laser now. Is that right?
Yes. So what we want to do now is take you guys to look at some cutting. So we will turn this off.
All right. Thanks everyone for joining us. My name's Ryan, and I am the applications engineer here. So I'm going to take you through a few different materials. First, I'm going to start off doing some materials. We're going to do some steel cutting with 2,000 watts. I'll do 60,000 steel, 1/4 inch and 1/2 inch. We'll go through those parts and then we'll kick it over up to 6,000 watts.
Ryan, you should feel pretty lucky. I was coughing pretty severely on some water here, but I had the foresight to actually mute my mic before I coughed.
Appreciate
I'm
it.
pretty conscientious, you know, that kind of guy.
I appreciate that. Yeah. Okay. So right now I've got a part with some 60,000 steel. So I'm going to cut that. So if we want to toggle over to the machine.
So how are you setting up this job to run, Ryan? Are you doing each sheet individually, or are we just kind of letting the laser skip from job to job?
You know, I've got it set up. I'm going to pause between so that I can take out these parts and show the edge quality. But I do have everything set up to jump into cutting straight into the parts.
Okay.
I've got some material on the other part too, though, so we'll get to see a palette change on here as well. And I also wanted to show, I've got some stuff that's not set up where we'll do drop and cut to show that too, which is a cool feature.
Yeah. Well, and I
so
think
right now,
even, let me just maybe kind of describe what's interesting about that. So this is one of the unique features that not only the 1030, but the whole Trump range of machines has. You can actually have a bunch of jobs set up on a single pallet. So maybe the front and back pallet have 4 different sheets with 4 different jobs. And so rather than having to have somebody come over and load up a new program in between or have it tied into a storage tower, you're actually able to go from job to job on a single pallet, which is a really cool feature of these machines.
Yeah, that's right, exactly. So this is the part that we just cut. So you can see we did some etching on it. I put some micro joints on there, but so this is what we're looking at for our edge quality. This is the backside. Really, I mean, beautiful edge. There's really no burr, you know, a little bit of a micro burr, but it's clean. So on this, we're cutting at 590 inches a minute. When we switch over to 6,000 watts, you'll see that we're cutting a bit faster.
And I think that's an interesting point. So you left some micro tabs on there. This control has the ability to set those, right? So if I were cutting the part and I said, oh my gosh, I've got some tip ups here, I can actually just set some micro joints dynamically at the control.
It does, yeah. Yep. So yeah, if I had a part and I was cutting it and I noticed that, you know, I've got one hole that's tipping up and I'm worried about crashing it, I can pause my program and I can go in and set micro joints and say, all right, this hole's, you know, a 2-inch hole. Capture anything between 1.5 inches and 3 inches, and it will capture that hole, and it'll put the micro joint on it. So it's nice that you don't have to go back to your computer and reprogram something. You can do that all on the controller.
Yeah, it's definitely cool, and it's graphical, right? So you're not going into the G code and saying, let's change the length of this
Don't need to touch G code. It's
Awesome.
it's a simple tab. Yeah, there's a micro joint tab right on the program. Just go in there and just put what dimensions you want to capture for a micro joint, and it will grab that.
Ah, very cool.
So yeah, so on that, we're cutting at 590 inches a minute with nitrogen. This next part is going to be some 1/4 inch. So like Brett had mentioned, on this, we are cutting with oxygen. So right now it's going to change the nozzle. The machine has an automatic nozzle changer, so it'll change as it goes between the programs, which you should see right now. And so while we're cutting, so we can cut 1/4 inch steel with oxygen with 2000 watts, and we're going to be cutting at 71 inches a minute on that.
And so we're also changing the gases automatically, right? So the first part was nitrogen. This is oxygen. There's nothing you had to do. It loaded up the right nozzle, it changes the gas inputs.
It's all in one cutting head. It's all, yeah, it will change the nozzles. It will change the gas between table. You know, these tech tables are just programmed, and it calls out what each program's going to use, and the machine does the rest. So press play and it does it.
Excellent. So it's interesting too, I note, so, you know, this being an oxygen cut, it's slower than nitrogen, but we have what's called pierce line control here. And you'll notice the pierces are really, really quick. So we have a sensor measuring back reflected light into the laser, and it says, okay, when I'm piercing, I get a whole bunch of light back into the laser. And when we see a reduction of back reflected light of around 70%, the laser in real time says, oh, I'm done piercing. Now I can switch over to the cut. And that's why you see really no pause in between the piercing process and the cutting process. It's communicating with itself.
Yeah, exactly. Yeah, the pierce on here is 1/2 second, unless it reads that it's through.
Which is cool. So that's our upper limit if we're on a slat or something. That's one of the cool things, like with the high-speed eco, you have what pretty much 0 seconds for a pierce on steel, 1/4 inch with a nitrogen process. That's pretty incredible.
Yep. So now with this part, yeah, got, you know, the oxygen edge. There's a little bit of etching on it, but that bottom, you can see that, that's your bottom edge. There's nothing on it. It's clean. It's clean. The advantage is when we go to 6,000 watts, it's faster, and we can cut it with nitrogen. So, you know, if you're trying to minimize your post-processing, that's a nice option too.
And so when we're going to the 6 kilowatt, now obviously 1/4 inch is a little bit thin for this, but we also get what the bright line fiber, right? So when we're going to, I think it's 5/8 and above is when it becomes active, we actually change the beam and the mode. So this laser has not only like a zoom optic, you know, like collimation in the head, but it actually changed the delivery core that's active. And so that would occur during the 6 kilowatt processing. So if Ryan's cutting I don't know, a chunk of 1 inch material, it would actually.
The 1/2 inch part that I'm doing is going to actually be with bright line.
Oh, okay, cool. And that gives us a beam diameter that, without changing the core, is 4 or 5 times larger than you can do with just simple optics manipulation. That's why you're less, you know, restricted by the quality of material.
So right now I'm actually just setting the laser diode. We'll do drop and cut when we go over to the 6,000 watts. So
Did
I
you
think this
spray
should be
paint
a good
this
spot for everybody to view. So yeah, so this is 1/2 inch.
It's
So
not
when we're
spray
doing
painted
half,
because it's very very textured. It's just what, an 836.
it is, yeah.
Mm-hmm.
Yep. So with the 1/2 inch, we're doing this with oxygen. It's a standard table, and this is 27 inches a minute.
Can you,
Now,
is
Ryan,
it
I don't know
possible
if
to,
we've talked about
So
it here, but the nozzle change there is needed, right? And we have concentric nozzles.
yes, that's right. Yeah, you know, it's changing as it goes between the different programs. It's picking the proper nozzle that, you know, that we spent quite a bit of R&D on developing, you know, for the best parameters as we go between all the different materials.
and I think the cool thing about the nozzles, you know, Soleil mentioned they're concentric. So we have basically a nozzle centering. So usually when you look at 9 Trump machines, you see there's a nozzle centering process. And the reason for the nozzle centering process is because the nozzle is just pushed into the cutting unit. So it's never going to be returned to 0. And so there's always an alignment that has to occur. So every time you swap the nozzles out, you have to do a nozzle alignment. It's not a beam alignment, but it's an alignment of the actual nozzle. So if you look at the actual shape of the nozzle that we use, and the fact that it's screwed in, the shape would be pretty similar to the European style press brake tooling a lot of us are familiar with. Same sort of concept. So when it's screwed into position, the tapered shoulder not only holds it into position, but it centers it, and that guarantees concentricity. So we have to very, very infrequently change the alignment of the beam to the nozzle, and there's no time required in between, and you get a part that looks consistent and clean like that. So that's 2 kilowatts.
Yeah, this is 2,000 watts. Yep. So clean edge, you know, you see a little bit of line striations. Once I cut the 6,000 watts, you know, I'll show both parts so that you can see the difference. 6,000 watts is slightly smoother. It's got a little more of that glassy edge, but yeah. So
Really good.
So at this point, we can go through the HMI, and I'll show you how that we switch that over to our 6,000 watt machine now.
So here, Ryan,
So,
just to preface, you're going to take us through a switch where you're going from 2 to 6, right? Nothing in between. There's no options in between. It's just 2 or 6.
that is correct. Yep. So we'll go over to our setup tab here, and you should be able to follow my mouse on here. So now when we're in our setup tab here, you see this little tab down here called Power by the Hour configuration. You just have to click onto this button. It says our current laser power is at 2,000 watts. So select laser power. It gives you the option 2,000 or 6,000 on here. So we want to switch over to 6,000 watts, set the laser power. Do you want to update it? Yes, I do. So hit yes to confirm. And now it's going to reboot the HMI, and it's going to change it over with the 6,000 watt tech tables.
Okay, so you said it's rebooting the HMI. I think that's kind of interesting because this is one really big difference between the Trump disc laser and the fiber everybody uses. The disc laser is the newest iteration of solid state cutting. So the first solid state source you had was a rod laser, very good for pulse processing, very poor for continuous wattage. So in the 80s, the fiber was developed to give us good beam quality and continuous wattage applications. They have a short shelf life though, generally due to diode failure, photo darkening in the core. And so the disc came out in the 90s. This is the most recent version of 1 micron laser cutting to resolve those issues, but it also contains what we call true control. And so Ryan is actually accessing the controller on the laser. So the laser itself has a control. You could say, hey, you know what? I want the machine. I just want the laser source. I'm going to, I don't know, aerate my lawn with the thing. So you could buy a laser and you would have all these different sort of behaviors defined. And you can't do that with a fiber. And that's one of the really nice things about this is not only can we reboot the system at a totally different laser power, But this is how we do things like get the power feedback from the sensor systems, right? So that's the Pierce line we discussed earlier, or even more importantly, we have what's called a closed loop power stability system. And this is a critical reason that we went to the disc originally and why we're actually introducing it on some of the actual fiber lasers now, like on our tube machines. We have the ability to control the power output by plus or minus 1%. And so generally with a fiber system, you have plus or minus 2% over a single shift. But because of the power losses, you don't have the same amount of power later down the road, whereas this laser does. So now Ryan's back up and running, and he's at 6 kilowatts. And because of the closed loop power measurement system, he's at plus or minus 1% of 6 kilowatts, even if this thing's 10 years old.
So Ryan, before we get away for the machine view, on the control panel there once more, because we're at the higher power level, can you just point out for everybody where they might be sure that they're in the 6 mode?
Yeah, absolutely. So if we were to go to our setup tab and hit the power by hour configuration, it will show you current laser power. Another way to do it is, now if we go to our tech tables, this technology tab shows us all the tech tables loaded on the machine. If I click here and I just say, okay, what tech tables are on here, you can see as I scroll through, everything here says 6,000 watts. So it's not going to show me any of the tables that are with 2,000 watts. So I would know if I was in this tab or if I was in the beginning on the power by the hour configuration button, that which power it's set on.
If you go to the production screen, it shows your current laser power too, right?
It not on the, well, yeah. So when you go into the laser cutting, yeah, it's going to show you your tech table, and it's going to say, okay, this program is using a 6,000 watt tech table.
Yeah.
So if you were on 2,000 watts.
Now, if you're in the production screen, when the job's running, it shows like the little trace of where you're at in the program. It'll tell you the readout for how much power is currently being used.
Right. Yep.
Yeah, so it's not even what power the tech table's for. It's like, this is the literal amount of power that's being measured by the system.
Yes. So while we have the screen up here, I'm actually just going to show another cool feature. So we've got something on here called drop and cut. So I can take my part and I can go post-production, and I will turn on the camera. I want to move that cutting head out of our way. So right here, this shows all the parts loaded in my program. If it had multiple parts on a sheet, it would show you multiple parts. Right here, I've only got the one. But here, for post-production, I can say, okay, I need a couple parts of this, a couple parts of that. Say one part got destroyed and you need to cut another. I can take whatever here and I can actually just click on it, and it's going to bring it over here, and I can say, okay, you know what? I've got this sheet and I know I can fit one here. I can fit, a couple parts here. It's kind of cool. So it gives you a nice way of utilizing some material and seeing what you can fit on a sheet. And just if you need to cut something quickly, it's a nice feature to just go in and do this really quickly to cut something. So we'll put it on there. And now it will, oops, gotta unlock the right one. Yeah, so now that part that I just dropped on the sheet, it's gonna go cut. So if we wanna toggle back over to our So when we cut this first part with 60 thou, it was cutting at 590 inches a minute. When we're cutting with 6,000 watts, the machine's actually cutting at 1,610 inches a minute. So it's a big jump. On a part like this, the first part that we cut, it was 27 seconds. This one's 29 seconds to cut it. So the reason being is that, there's a lot of intricate geometry. So it doesn't have all the time to get up to speed, except for on some of these straightaways on the part. Now, as we go up into some of the thicker stuff, you'll see it's a bit more drastic in our speeds.
This is exactly where having that ability to do kind of the power switch or this on-demand power with the program Power by Hour would be really helpful for somebody.
Absolutely. So you can see it's laser etched. That's what it's doing when the laser beam first comes on, is it's etching, and then it's cutting this part. So, yep, you can see the bottom. It's clean. I mean, there is nothing on here. So, yep, it's a nice option. And it shows well as we get into thicker. So I'm gonna do some 1/4 inch next.
So this 1/4 inch part's cut with nitrogen, right? Rather than oxygen this
So
time?
yeah, so the difference on here is the first 1/4 inch part that we cut, we did it with oxygen. Now with oxygen, there's post-processing involved and it's slower. So with our oxygen, we were cutting at 71 inches a minute. Now we're cutting with nitrogen at 177 inches a minute. So this part with oxygen is 1 minute and 19 seconds. Now when we switch over to nitrogen, it's only 48 seconds.
Okay.
So while that is happening, Brett, I'm going to take a look at our questions box for anything in here. Okay. Maybe I can ask you one of these questions.
Okay.
John has a good question. Do you think you could answer that one for our audience?
Very good chance I can. I just have to figure out how to open this thing.
I will happily read it to you. He asks, how is the reprogramming handled when moving between powers, as the parameters may be different depending on hole diameter possibilities?
Good question. It is a good question, and there wouldn't be any difference. So the way that Trump's machine works, that realistically is a little bit different, is that the code that you're generating in the offline programming software is just positional. So it says laser, go here, then go there. The behavior of the laser and the knowledge of the cut is actually on the control itself. And so if we within this program, boot it up at a different power level, or if Ryan just says, well, I programmed this with a nitrogen cut, I want to go with a compressed air cut, you can click on a drop-down menu, select the compressed air cut, and the whole behavior of the laser changes. And that also is going to include the different hole diameters. And so the different power levels in the different processes have different kerf diameters. So especially if you're going from nitrogen to oxygen, the amount of material that's being removed is different. And so we have what we call kerf correction. And so the kerf value is actually inside of the control. So it would say, oh, we're going to nitrogen, the kerf's smaller. I actually need to shift myself out a little bit more. So what that, I guess, is a long way to say is you don't have to do anything.
Thank you, Ryan, for showing us those parts too, as we were helping John understand his question.
Yeah, you're welcome. And I'm gonna swap our palette changer real quick here. So one thing I just wanted to do is actually show a side by side here. So this is the one that I just cut with nitrogen. So the one on my left, I guess, yeah, so the one on the left is with nitrogen that you're looking at, and the one on the right is oxygen. So you can see the oxygen's a little bit smoother. Yeah, I mean, they're both, there's no burr really on either. But you get a great amount of speed advantage, 177 inches a minute versus 71 inches a minute. And no post-processing with nitrogen. So certainly an advantage. Now, when we go up to 1/2 inch, we're going to see even bigger difference here.
While that is happening, I'm going to answer another question here. What does, say, the customer have to do, or what's, absolutely required, I think is kind of the question here. Well, the machine needs to be connected to the condition monitoring portal at all times. You have to have an internet connection, so that way we can keep track of that data usage for the per minute at each power level. That would really be needed. But say, for example, your internet connection doesn't work. We've all experienced some weather-related issues over the course of the year, or it's just your internet goes out. If there is a missing piece of data due to an interruption in the internet connection, then we would ask the customer, you guys, to get in touch with us and tell us what the usage was through the log files that are on the machine. And of course, we would walk you through the steps of how to do that. And that would be the best way to mitigate that.
Yep. So I'm going to start this 1/2 inch program. So with 2,000 watts on 1/2 inch steel, we were cutting at 27 inches a minute, right? Now we're cutting at 79 inches a minute. So this is going way faster. So this 1/2 inch part with 2,000 watts took 55 seconds with 2,000 watts. Now we can cut the same part in 22 seconds. Sorry, I'm just gonna grab my other part if I can find it. I think it was this one. Okay, so this is 6,000 watts. This is the bottom of our part. Now if we do side by side, you can see the one on the right was 2,000 watts. You see there's a little more striations in the side. The one on the sorry, which way we're looking, on the left, it's like glass. So a lot smoother, a lot faster. Like I said, this part was cut in 55 seconds. This part was cut in 22 seconds, and it's cleaner. So it's nice option with the 6,000 watts there. I don't have anything else to cover. So I'll hand it back over to Soleil and Brett.
All right. Thank you very much, Ryan.
Yeah, thank you very much, everyone.
A follow. We'll turn over to the questions again and follow up to John's original question, and you're very welcome. We're happy to answer your question, John. You asked actually a very good follow-up question. So in the case that you have a hole that had been etched on the part because it was too small to be cut, and you changed the process, and now, okay, I can actually cut the part out. In a case like that, you would need to reprogram because we're using different what we call rules. And so rules are like behaviors. So the control wouldn't be the master of these sort of things. That would be the programming software. And so basically what we would have to say is, okay, we're doing a small contour, maybe it's half of the material thickness with oxygen, and then at that point we need to do like a reduced lead-in where the power level is lower at the start. So if you're changing the rules, then you would have to reprogram. If you're not in a case where you have to change the rules, and so primarily that would be if you're cutting with nitrogen, you're going to be able to pretty much change it across the board. And for the most case with oxygen as well, just if that hole gets to be half of the material thickness or so, that's when it gets a little bit more difficult without actually going and modifying the text directly in the code. So it's easiest just to post it after that point. Shane asked do you have to have a different post in TruTops? Is there an easy way to see the time differences? That's a good question. So with the control or the newer versions of Tops now, so it's been like a year and a half, we have a really good post processor. So when you get a time estimate out of our software, so if you call up Ryan or one of his colleagues and say, hey, we want an estimate on these 10 different pieces about how long it's going to take to cut, we're good to really high accuracy. 5% typically, outside is 10, and that's really way outside of what the norm would be. And so we have a very good representation, and that's pretty important. So if you're programming with a different power level, of course, and I'm trying to quote a job, you really do accurately want to know how quickly you're going to cut the nest. And so in that case, you wouldn't need a new post. You would just use a different laser power. So it is possible that you use different power levels. It would only be if you said, okay, well, I'm programming 3030 instead of a 1030, where you would need a new post, but just different power levels could be changed.
So there's another question, Brett, here from Scott that started at the beginning. Is the 225,000 per laser? The answer to that, Scott, is no. That is, let's say, if you wanted to kind of buy out the higher power level and stop receiving monthly payments from us. So this kind of like feeds on to another question that we get asked commonly is, if you guys want to stop receiving monthly invoices from us for this Power by the Hour program, you can stop using the higher power levels. So then at the end of the month, when we query the data report, we'll see 0 minutes used for that month at the higher power level. So you wouldn't get any more invoices. Or yes, you could just elect to kind of opt out of the program by saying you want to have the higher power level by purchasing that differential, which is $225,000.
Okay.
Brett,
so
we may have time for like one more question if you want to find another one.
I think maybe I want to answer 2 questions, and the second one's pretty simple. So we do have one question from Ryan asking, why do we have to start the laser between doing a switch in power levels? And so again, if you remember, I had mentioned that the TruDisc laser has what we call true control. So if you look at the cabinet, you've got this big box here. The majority of the box isn't the laser. So the laser source sits on top of the sensor and the IPC and everything. So there's a computer underneath the laser that actually contains all this information. So what Ryan's doing is he's just restarting the control in a different power level that then is being interpreted by the actual HMI on the machine. So we're rereading the control. So we're breaking the connection so we can reestablish it basically. And then I think good question here is the demo in Connecticut or Illinois. It's in Connecticut, so all of the machines are produced from top to the bottom. The 1030, 1040, 3030, 3040, 3060, 5030, and 5040, right, Slay? Nope, I am missing one, 2030.
We are also doing, yes, the 2030, exactly. So everything is manufactured by Trumps. It's done here at Trumps, our U.S. headquarters in Farmington, Connecticut. We do also have, yes, the showroom or the smart factory in Illinois. There's also Trump LA and a couple of others around the country, around North America, really. We had another question in here. Will this presentation be available for you guys afterwards? Absolutely. I think that our master of the controls, Mike Gordon, who's operating all of the cameras in the background for us today, will post this up to YouTube afterwards. So if you guys do want to watch back or share it with your colleagues, you can totally do that. So let's maybe close out. Ryan, I think you have some really thick parts in your hand you want to show us. If you could just talk about those for 2 seconds, and then we will wrap it up for everybody today.
Thank you. Yeah, one more thing I just wanted to mention is, so here's some 1-inch stainless that we cut on here. So yeah, this is what it's going to look like with 6,000 watts. Now, if we were doing that with 2,000 watts, we max out at 5/16. Now, this is 1-inch steel. We max out at 5/8 for steel. So, you know, this is steel with 6,000 watts. This is what it's going to look like. I don't have an aluminum sample, but aluminum on 6,000 watts, we also can do 1-inch, whereas with 2,000 watts, you max out at 1/4 inch. So just more stuff to consider. Very, very cool option. You know, I think it's cool that we're doing this. So just wanted to show a couple more samples.
Thank you, Ryan. All
Yeah,
right.
thank you.
If we didn't get to your question today, because we are sensitive to everybody's time, we are a bit over. We can be reached. You're welcome to contact us through our TruLaser inbox. Mike Gordon may also grab the rest of these questions and send them to us that we can help answer for you guys more one-on-one afterwards. And you are always welcome to ask for an in-depth personalized demonstration. So with that, thank you to my teammates and everybody that joined us today. Be safe, be well. Bye-bye.
All right, bye.
Thank you for joining us. Thank you, everyone.